So looking at question number 24 at the MAC 1140 final exam review for pre-calculus, we can see that it's stating to find the exact values of the following logarithmic expressions, and we are given 4 expressions. So let's go ahead and start by looking at A. We are given log base 3 of the argument 1 divided by 243. I'm going to go ahead and rewrite this in exponential form, and when I do that, it's going to be 3 raised to the power of x is equal to 1 divided by 243. And I'm going to rewrite 243 as 243 raised to the negative power of 1, because when you raise it to a negative exponent, it automatically flips it in fraction form. So now we're going to go ahead and see if 3 has any number that it's raised to equal 243. So I'm going to plug in some values to my calculator just to test, and I'm going to try 4, which is 81. And I'm going to try it raised to the power of 5, which is, believe it or not, 243. So we know that 3 raised to the power of x is equal to 3 raised to the power of negative 5. Remember how if we have the same bases, we can set the exponents equal to each other? So when we do that, we're left with x is equal to negative 5. So that is the exact value for A. Now looking at B, we're given log base 2 of 0.00986. There's no easier way to do this than to just plug it into your calculator, unfortunately. So when we do that, we get the value of negative 6.66 as the exact value of log base 2 of the argument 0.00986. Now looking at problem C, we're given the log base 7 of 1. I'm going to rewrite this again in exponential form. And when I do that, I get 7 raised to the power of x is equal to 1. And we know that from college algebra, any number raised to the power of 0 is equal to 1. So we know that x must be 0. We also know the logarithmic rule that when you have a log with any base with the argument of 1, we know that that's also equal to 0. So the exact value for C is 0. Lastly, looking at D, we're given log base 4 of 256. I'm going to rewrite this in the exponential form. So you get 4 raised to the power of x is equal to 256. And I'm going to raise 4 to the power of 3 to see if that works, which does not, because it's 64. Let's try 4 raised to the power of 4. Luckily, that's 256. So we know that 4x is equal to 4 raised to the power of 4. And again, same base, you can set exponents equal to each other. So this means you are left with x is equal to 4. And that is the exact value for D.